Hello, our team composed of Melanie Martinez, Kevin Martinez, and Martin Galicia got the task to design a car using the 3D software Creo Parametric. To complete the project, we went through three main stages: reverse engineering, where we disassembled a physical car that was given to us; the analysis, where we identified the purpose for all the pieces; and the design of the final 3D car. This was a challenging project since we went through many obstacles, but in the end we overcame them and developed various skills.
The purpose of this project was to design a body for a radio control car that was provided. This new body should be based on the way Local Motors designed the Stratey, which was the first 3D printed car to be fully functionally sticking to the concept. We designed a body that could hold all the components without the need of a chassis to hold everything in place. The design was later sectionated in order to be 3D printed, as the dimensions were too big for the printers that we had available.
Reverse engineering is the process in which a product is disassembled in order to understand its components and the way it works, in order to solve an issue or just improve the product. We approach this by disassembling the car starting with the rear side to finish with the front. We measured all pieces using a vernier caliper and divided them so every member could do a 3D design of it. Once we had all measurements, we analyzed each piece to determine their function and if we needed them for our final design.
The shock tower function is to support the components of the transmission in place. This piece was designed in order to hold most of the transmission's components, as well as to hold a body mount that was later on used to secure the cover of the car. As we redesigned the cover, we realized that this piece would be the key to hold all the components into our new cover design. This is why we use this piece as a reference by creating a cutout in Creo Parametric in order to place the holes needed to screw the piece into the body. The shaft is the piece in charge of giving the mobility to both the frontal and rear suspension. This piece contains a set of gears and bearings that connect directly into the motor and then into the differential. Due to these gears, the impulse needed to move the car is created.
The differential is a device that splits the engine torque two ways, allowing each output to spin at a different speed. The differential is found on all modern cars and trucks, and also in many all-wheel drive vehicles. These all-wheel drive vehicles need a differential between each set of drive wheels, and they need one between the front and the back wheels as well, because the front wheels travel a different distance through a turn than the rear wheels.
The suspension is a crucial part of any car. It helps the car to keep the equilibrium once in movement and give it stability when turning. The suspension is composed of different parts such as spring, which makes it possible for the suspension to contract and expand once the car passes through uneven roads. It also has the lower spring retainer, which prevents the spring from separating. The suspension contains a piston and special shock fluid to help it move. All of these pieces are essential and they must stay in the final design.
The servo increases the steering response of the Apex car. It is designed to create a 180 degrees movement. This creates the steering movement of the wheels by using a dog bone to connect the servo and the transmission. To maintain the original functionality of the part, the servo was used in the design of our car. The servo used in the car was designed at a smaller scale of a steering mechanism. It covers the same function of a real car. The design of it was to be similar to the real one, in a cheap and resistant presentation. The gearbox protects the differential and the gears of the shaft. In a real car the function is the same. It protects the gears, which are selected by a system of rows and levels operated by the gear lever. Due to the components inside the gearbox, the speed and torque moves from a rotating power source to another device.
The chassis is a big platform used to hold all the pieces inside the car. It is big enough to hold the battery and the servo, as well as the shaft, gearboxes, and the electric wiring. Since our design is made from cutouts on the bottom, the chassis will not be needed. Therefore, its 3D design can be skipped.
The chassis top plate is the component in charge of protecting the most important systems of our Apex car. These systems are the shaft, the differentials, and the motor. In addition to its protection purpose, this component is used to attach the shock towers and the gearbox into an assembly that was later on screwed into our Apex body.
During the 3D printing of our project, we faced with some challenges which occurred naturally. The 3D printers available for use presented some issues when loading or printing the filament. We became familiar with those problems and looked for ways to fix them, giving us more experience when using 3D printers. Another issue we faced is that the ground cable connected to the motor broke, which made us have to solder it back. The first designs we made were far from the desired one, meaning that we had to correct them and print them again.
This design was the first body printed. This design was not created in the most efficient way. For instance, the design did not include an appropriate shape, and the cuts were not big enough to include the mechanisms used in the Apex car. Of the new versions printed, the material and time were reduced from 7 hours to 5 hours.
The second try, we started to reduce the height of our model so we can save printing time. We also made the compartments for the components bigger so they could fit. What we did not take into consideration was the part in the middle, since nothing will fit in there.
For our third trial, we decided to come out with a new design for our Apex car. We decided to make a cut in the middle of these parts in order to be able to assemble the components here by screwing the shock tower in, as well as making the holes a little bit bigger in order to secure the components will fit in. In addition, we decided to add these shafts and holes here in order to assemble these two pieces, but a mistake was made. As we were designing in Creo, we added a same diameter to both shaft and hole, but we were not counting on the tolerance we should have given to the printing. So in this case, even though the design had the same diameter, the actual piece didn't fit in.
4 version printed. The new modifications of these versions were to change the diameter of the shafts in order to secure the assembly of both pieces. The cuts were made deeper to reduce the time and material used. We also make bigger this cut to assure the suspension will fit.
To be assured that the cut for the shock tower worked, we started to make empty spaces bigger so the electric components could fit better. However, the shafts are still bigger than the holes, making it impossible for them to fit.
For our last trial, we decided to make the middle part hole as well as the diameter of the tires hole a little bit bigger to assure that all the components will fit. In addition to that, we decided to change the filament used to print. Instead of continuing using ABS, we changed to PLA. Lastly, we were able to change the infill percentage to a higher number in order to have a higher quality piece.
We decided to make the rear part following the design from the front part, adding a place where the shock tower could be screwed in order to secure all the mechanisms. We decided to add multiple holes to make sure the shock tower will fit.
¡Kevin!
Mano, eso con mano. Mano negra ahí. Falta. Güey, no, qué raro, güey. Lo tengo bien seguido. Dale más vuelta, más pegar. ¿Cuánto? 40.